Hi, this section is on Venn diagrams. So I'm going to cover Venn diagrams in the workbook here. It says section 5.3. It may not match up with the book that you're using. It may be section 2.3 in the book you're using. But let me cover Venn diagrams. So I'm going to start on question 3 on this workbook. Okay, so let's try to draw. It says draw a Venn diagram. So here's my set, and we're going to call this the universal set. This is the universal. Everything in our universe is right in this square. The universal set is a set of all natural numbers. Natural numbers start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all counting numbers, 12, 13, and so on and so on and so on. Let T represent the set of natural numbers less than 10. So these, maybe I should have, let me clear this off. Let's try this again. Maybe I should have read this first. So this is the universal set. T, this circle T is the natural numbers. We're going to call it T. Natural numbers less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And S represents this. 10 is not in that set. Let S represent the set of single-digit natural numbers. T represents the set of natural numbers less than 10. And S represent the set of single-digit natural numbers. Well, that doesn't, I mean, we can keep on going. 10, 11, 12, 13, 14. Do you see? Numbers less than 10 are only in T. Numbers greater than 10 are not in T, but they're part of the universal set. And let S represent the set of single-digit natural numbers. So these are all single-digit natural numbers. So this is also S and T. That's kind of a weird question. I'm not sure if that made sense. Let's get to a real example. Here we go. So here's a real example with numbers in it. So once again, the universal set is the box. Everything in our universe is in this box. Determine the following sets. So A is a set of numbers, and everything is in A. A is this circle right here. So the set that's in A is 1, 3, 5, 6, 7, and 9. So that's everything in A. The set of elements in A, but not in B. So which elements are in A, but not in B? Do you see how 6, 7, and 8 are in A, but they're also in B? B is the other circle there. So this is B. This is the B circle. And A is the red circle. So the set of elements in A but not in B, 1, 3, and 5 are in A, but they're not in B. Okay, that's not too bad. So next is the set of elements in union in the universe, but not in A. So we're talking about all numbers that are in our universe, but not in A. So 4 is not in A. 4, 8, 4 and 8 are not in A. Also, 2 and 10 are not in A, but they're in our universe. So these are all the numbers in the universal set that are not in A. And then finally, a set of elements in both A and B, and that's 6, 7, and 9. You see 6, 7, and 9 are in both the red and the blue circle. It's where they combine together. We got more. If I can scroll up and down. Set of elements in B that are not in A. So what are the elements that are in B but are not in A? That's 4 and 8. They're in B, but they're not in the red circle. So that's 4 and 8. The set of elements in neither A nor B. What are the elements that are in neither A nor B? So they're not in A and they're not in B. And there's only two elements that are not in A and not in B. That's 2 and 10. Do, 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 do. 2 and 10. All right, so that's not too bad. Let's see if they can try to trick us with anything. What else do we got here? Okay, we don't have a Venn diagram, but we have numbers up here. The universal set is 0 through 9. A is 1, 2, 5, 6, 8. B is 1, 0, 1, 10. 0, 1, 5, 7, 8, 9. So find the elements that are not in A. So here's A, 1, 2, 5, 6, 8. So everything that's not in A, we just look at the universal set. Look at the universal set. 0 is not in A. We already said 1 is in A, 2 is in A, 5 is in A, 6 is in A, and 8 is in A. So 0 is not in A, 3 and 4 are not in A, 7 and 9 are not in A. So these are all the elements that are not in A. That A prime means not in A. What are all the numbers not in B? Well, B is 0, 1, 5, 7, 8, 9. Look at the universal set. Which numbers do we have in the universal set that are not in B? 2 is not in B. 3 is not in B. 4 is not in B. 6 is not in B. And that's it. 2, 3, 4, 6. Here, this symbol, we talked about, we briefly mentioned that in 5.2, but that means intersection. And intersection means what's in common. So what's in common with A and B? Look at set A and look at set B. Do you see how 1 is in common with A and B? 1 is in common with A and B. 5 is in common with A and B. 6 is not. 8 is in common with A and B. So these are the three numbers that A and B have in common: 1, 5, and 8. Now, this is not intersection, this is the union. A union is like a marriage. A union is like a marriage where if you have two people that get married, I have my stuff in my apartment. She has her stuff in her apartment. We move to a new apartment and we bring everything into it. Now, if I have a fridge and she has a fridge, obviously we can't bring two fridges in the apartment. We have to get rid of one of them. So that's what a union is. You bring everything into one apartment. So here is the set symbol for our new apartment. So we're going to bring everything into this apartment. A has a 1, a 2, a 5, a 6, and an 8. These are A's: 1, 2, 5, 6, and 8. So she brought all her stuff in. I'm B. I have a 0 in B. I have a 1, but there's a 1 already in there, so we're getting rid of one of the fridges. There's a 5. I have a B, in the B set, there's a 5. There's a 7. There's no 7 yet, so we have to put a 7 in here. There's an 8 already in A, and finally there's a 9. So this is a union of A and B. She brings all her numbers into the set. I bring all my numbers. If there's a repeating number, we don't write it twice. We only write it once. Okay, set A. The next problem is set A intersecting with the empty set. So what's in common with A and the empty set? Well, A has an empty set. If I take everything out, it has an empty set. So the only thing in common is the empty set. If I have B union the empty set, what's in common? Or B is a union, is a marriage. So then the set for B would be B union empty set would be the same thing as B. 0 because of the union. If he's B, 0, 1, 5, 7, 8, 9. And it's a union with the empty set. I don't know if we would put 0, 1. That's supposed to be a 1. I don't know if we put an empty set in here. I'm going to say no, we don't, because we can take everything out and call it the empty set. Let's see what else we have here. Okay. So they're getting a little crazier now. This is good. So once again, here's a universal. This is everything in our universe. We're only looking at these numbers for this problem, the universe. What is A union B? This is a marriage, except I didn't spell marriage. So this is a union. It's a marriage of A and B, but then they said not. So first you want to find a marriage of A and B. Before we do the not, you do the marriage of A and B. So here is the marriage of A and B, A union B. A has 1, 2, 5, 6, and 8. B has 0, 1, 5, 7. We don't have 7 yet. 8 and 9. So this is the union. This is the marriage of A union B. But then there's a not. So look at so this is A union B. We want to know which of these which numbers are not in A union B. So A union B says not. So out of the universal set, which ones are not here? And if I have 0, 1, 2, if you look, 3 and 4 are missing. Those are the ones that are not in A union B. 3 and 4, 5, 6, 7, 8, 9. That's it. Just 3 and 4 are not in the union of A and B. Do you see that? So the answer to this problem is just 3 and 4. Which problems are not in the union of A and B, and just 3 and 4 are not in it. Okay, so here's example 7. First, we want to find not A. So we're going to write the set of numbers that are not in A. They're in the universe, but they're not in A. A is 1, 2, 5, 6, 8. The numbers in the universe that are not in A are 3 and 4. 3 and 4 are not in A. 7 is not in A. And 9 is not in A. Then we want to find the numbers that are not in B. B has 0, 1, 5, 7, 8, 9. So the numbers not in B, but they're in our universe, but they're not in B, are 2, 3 is not in B, 4 is not in B, 5 is, 6 is not in B, 7, 8, 9. So these are all, this is not A, not in A. These numbers are not in B. We want to find out the intersection, what's in common with both of these. Here's not A, here's not B, the intersection. What's in common? If you notice, 3 and 4 are in common with both of these. So A naught intersect B naught. The answer is 3 and 4. I could draw my sets a little bit better. So the answer to this problem is 3 and 4. So there's a lot of thinking here. You kind of like have to write down each part. All right, so let's take a look at this one. Here's the universal set, and we want to find a union. Union is a marriage, right? When you form a marriage, it's a union. Marriage. So everything that's in A is 1, 3, 5, 6, 7, 9. That's all A. Everything in B is 6, 7, 9, 4, and 8. So this is everything in A. This is everything in B. We're going to form a marriage, a union, a one. That means all the A stuff comes in 1, 3, 5, 6, 7, and 9. All the B stuff comes in 6, but we already have a 6. 7, we already have a 7. A 9, we already have a 9. 4, so I have to add a 4 in here. And an 8. I have to add an 8 in here. And so this is a union of A and B. Okay, so the next question says A union B. Here's A union B. We already found that. But not. What are the numbers in the universal set that are not in A and union B? So we already have A union B. Which ones are not? Well, 2 is not. Do you see 2 is part of the universal set? So is 10. 2 and 10 are the only numbers that are not in A or B in this, or not in this group right here. 2 and 10 are the only ones that are not in A union B. If, once again, this is the A and this is B, what's in common? What's the intersection with A and B? And that's 6, 7, and 9. Those are in both. Those are in common with A and B. Okay. And we have more. So if 6, 7, and 9 are A intersect B, which ones are not in A intersect B? Do you see? There's the not symbol. The same one we just did, but it says not. So if 6, 7, and 9 are A intersect B, is that the last one I did? Oh, wait, that's not. Is that the A? Yeah, 6, 7, and 9 are what's in common with A and B. So the next problem is what's not in common with A. Pretty much it's everything else in the universal set. So let's look at the universal set. So these are the 3 that are in common. these three here, which ones are not those? 1, 5, 3, 4, 8, 2, and 10. 1, 5, 3, 4, 8, 2, and 10. And you want to put these in order from lowest to highest. But these are the ones that are not in the intersection. There's the intersection. These are ones that are in the universal set, but not in the intersection. Okay, so we have a couple of more. So in order to do these problems like this E, you have to write each set out separately. So first we want to write the numbers that are not in A. So I'm going to write the numbers that are not in A. Let's look at the set. Which numbers, maybe I should clear it. Uh, let's look at the set. Here's A. These all these numbers are in A. Which numbers are not in A? 2, 10, 4, and 8. The numbers not in A are 2, 10, 4, and 8. 2, 10, 4, and 8. Those are the numbers that are not in A. And we're going to union this with everything that's in B. B has 6, 7, 9, 4, and 8. B is a little messy, but B has 6, 7, 9, 4, and 8. 6, 7, 9, 4, and 8. And we're pulling a union on these, a marriage. So that means all these numbers are going into the new set. And I'm going to try to put them in order. We have a 2, we have a 4, 2, we have a 4, we have a 4 over here. You only write it once. 6, 7, 8, 9. 6, 7, 8, 9. There's an 8. Is there any number? Oh, and there's a 10. 8, 9, and then there's a 10. And this is A not union with B. All right. And there's one down there at the bottom. I'll let you guys work on that. Okay, so now question 9 says find the cardinal number of the union of the two sets. A contains 95 elements. Let me try to write this somehow. Here's set A. B contains 84 elements, and 25 elements are common in both A and B. So if I have a set here, do you see 25 elements are in A or B? You're always going to write the intersection first. 25 elements are in common with A and B, okay? Now it says A is 84. Well, I already see 25 elements in A. That means how many elements are in A but not in B? This is set B. 25 are in A and B. And it says 84 elements are in A altogether. 84 minus 25 is 59. Do you see 59 and 25 is 84? It says there, oh wait, B contains 84. So there should be 59 over here, sorry. A contains 95. So it's 95 minus 25, which is 70. So let's look at this again. A has 95 elements. 70 and 25 is 95. A has 95 elements. B has 84. 25 and 59 is 84. And 25 elements are in both A and B. That's true. How many elements are in A union B? So when we add up all these elements, how many are there? We just add up all these numbers. You can't add up 95, 84, and 25 because because this 25, it gets counted twice. So now I have 70, 25, and 59. I just add those up. 70 plus 25 plus 59. 70 plus 25 plus 59 equals 154 elements. Do you see, even though it says 95 elements are in A, it doesn't look like there's 95, but there are. There's 70 here and there's 25 there. The first thing you want to write down is what's in both, because then if you write 95 first, that's kind of wrong because 95 adds up everything that's in A. Let's try this next one here. In a survey of 200 voters, so we know there's 200 altogether, 96 people said that economy was top, 97 says security was top, and 29 said both. So I'm going to write both first. Look at that. I have two circles, and 29 is both. 29 is both. It says 96 says economy. I'm calling this economy. The other one says security. This is B, security. So if 96 people said the economy, how many people are in the economy here do I put right there? I know there's 29 that said both. It said economy and security. So if 96 is economy, I'm not putting the 96 up here, but 96 is economy, I'm going to put 96. But that's not where you normally put it. It has to add up to 96. In other words, if I do 96 minus 29, 96 minus 29, I'll get 67 in here. 96 minus 29 is 67. Do you see when I add these two up, I now get 96. That's how many is in E. Now, the other one said 97 is in security. So if the 29 is in common, I'm going to do 97 minus 29. 97 minus 29, and I get 68. You see, now if I add those two up, I get 97, like I'm supposed to. It says how many people in the survey thought the economy or national security was the top issues. So or is a union. So the question is, how many people in the survey thought economy or national security was one of the top issues? That's a union. That's pretty much a union, a marriage of everything. So once again, we're going to just add all these up. 67 said economy, 29 said both, plus 68 said security, and the answer is 164 if I added all three up. How's this for a question? How many people said neither one of these was the top issue? How many people said something else is top issue? Well, look up here. It said 200 voters altogether. So in our universal set, we said we added up to 164. So there's 36 people that didn't vote for security or economy. Do you see? There's still 36 people in this universal set. So how many people said economy or something else other than economy and security? 36 people are not part of that because there's 200 people total. And that was the section 5.3.